Okay, let us now develop the delete node function for the circular linked list. The delete node will always delete the first node of the circular linked list. That means the node at the front of the list. First of all, what we need to do is to check if there is any node in the linked list. If the linked list is empty, we are just returning an absurd value from the list. Now the next thing is that we are assigning the address of the first node from the list arrow, tail arrow next, lstptr arrow next, tail arrow next. That's the address of the first node that we are assigning to p, node pointer p. So p is right now the node that we are supposed to delete, and we can get the data out of that node p. So p arrow data that we are supposed to return at the end. Now if this node is the only node in the linked list, then we need to assign null to the tail. Okay, so we can check if this is the only node, lstptr arrow node count. If that is 1, then there is only one node. You can check in the other way as well by using the pointers. If the lstptr arrow tail, that means the address of the last node, that equals with the address of the first node, that means lstptr arrow next, arrow tail arrow next. Oh, let me write in that way, that will make sense to you. So lstptr arrow tail, if the address of the last node equals with lstptr arrow tail arrow next, that is the address of the first node. So if the address of the last node kept in the tail pointer equals with the address of the first node, that means there is only one node in the linked list. So in this case, lstptr arrow tail, that should be null. Otherwise, if there are many nodes and we are supposed to delete the first node, that means the node pointed by p, then the lstptr arrow tail arrow next, that should point to the second node right now in the linked list. So you can just copy this. That should actually point to p arrow next. Now the p arrow next is the second node, that will now become the first node as we are deleting the first node. One more thing that we need to do here, we need to decrement the node count by 1. So node count minus minus. So that's how this is going to work. I'll just draw an image and I'll show you how this is going to work there. So if there is only one node, let us consider that the linked list with one node is there. So here is our tail. So the address of this node is 1000 and this is pointing to itself, right? And tail also contains 1000. Now we are checking lstptr arrow tail, that is 1000, and lstptr arrow tail arrow next, that is also 1000. That means there is only one node. Now what we are doing here, we are just assigning null to this. This is right now null because we are going to delete this only node, and p is this one. Okay. Otherwise, if there are many nodes, then what it should do, we should just delete the first node. Let me explain that logic as well. Say we have many nodes here in the circular linked list, and the tail pointer is pointing to the last node, and the next of the last node is pointing to the first node. So there are 3 nodes, and 1000 is here. So we have kept p in the first node. As you can see, tail arrow next is 1000 that we assigned here. So p is the first node that we are supposed to delete. Now this fails because there are many nodes. So tail doesn't equal to the tail arrow next. So we come to the else part, and tail arrow next, that means we are actually referring to this particular next pointer field of the last node that is assigned with p arrow next. Now p arrow next is 2000. That's the address of the second node. So that we are assigning here. So this next pointer field will now point to the second last node and not to p. So this is going to point to this one. Now we are just free to delete that node pointed by p, and that we can do just by using the free p function call. So let me do that. I forgot to do that actually. We need to deallocate that node because we have allocated all these nodes dynamically. So once we are deleting it from the linked list, we should deallocate that by using the free function call. So that's all for this. We have successfully written the delete node function. We'll check all these operations at the end of this series. Okay, we'll run this program at the end of this series. In the next tutorial, we'll be actually building the find operation and the print list operation. Okay, so these are the two functions that are left that we'll be doing in the next tutorial. Thank you for watching.